Okay, so we've got question 8. Two perpendicular lines. So we know we're going to be dealing with perpendicular gradients being the negative reciprocal. We know it. Line L2 passes through the point B, which is 8, 0. Show that an equation for line 2 is 5x plus 3y equals 40. So we can first find the gradient of line 2 because, as I say, we know that it's the perpendicular line to line 1 and its gradient is therefore the negative reciprocal of 3/5 minus 5/3. We've got a point on the line, so we can just sub it in to y minus y1 equals mx minus x1. So y minus y1, which is 0, so actually y minus 0 is just y, so we'll just leave that as it is, equals minus 5/3 x minus x1, which is 8. Let's multiply through by 3, and then we can expand the bracket, minus 5x plus 40, and then just bring the minus 5x over to the other side so that we've got it in the form that they wanted it, 5x plus 3y equals 40. Alright, so that's very straightforward. Part B, maybe a little bit harder. Find the exact area of triangle ABC, giving your answer as a fully simplified fraction. We'll get to that when we get to it. We know these two things. Lines 1 and 2 intersect at C, which is a point on this triangle then that we're making between those two lines and the x-axis. Line L1 crosses the x-axis at point A. So there's our triangle clearly defined. We can work out the area of a triangle by doing half base multiplied by the perpendicular height. That's the easiest way to find the area of a triangle. So if we knew that base length between A and B, and we knew this height up to point C, we could figure out the area of the triangle quite easily. So all we need to do first is to find what is that x ordinate over there so that we can measure the magnitude from A to B. Well, A is the x-intercept of line 1, so set that equal to 0, and we'll find our x-intercept. So 0 equals 3/5 x plus 6, means 3/5 x must equal minus 6. Multiply both sides by 5 and divide by 3. X is minus 30 divided by 3, minus 10. So that coordinate there is minus 10, 0. So we now know that the base of this triangle is 18 units wide. We've got to find the coordinate of point C to get that y ordinate that will give us the perpendicular height of the triangle. So that's the point of intersection of two straight lines. We're dealing with a simultaneous equation then here. So lots of ways we could do this. We could do it by elimination. If we rewrote line 1 into a form similar to this, we could get our coefficients the same and solve it that way. But instead, I think I'm going to take my equation for line 2, the one we just did in part A, and rewrite that to make y the subject. So y would be 40 over 3 minus 5x over 3, or 5/3 x, same thing, but I'll just write it that way. Just so it's consistent with how we presented that first one. Really doesn't make any difference at all. At the point of intersection, those two lines are equal. So we've got 3/5 x plus 6 equals 40 over 3 minus 5/3 x. I've got two different denominators here, so to clear those all away, I'm going to multiply through by the lowest common multiple of those denominators, which is 15. So multiply this by 15, multiply by 5 first to clear the 5, then I've still got to multiply by 3, so that'll give me 9x. Multiply 6 by 15 and I get 90. Multiply 40 thirds by 15, times by 3 gets rid of the divide by 3, I've still got to multiply by 5, giving me 200, and multiply this by 15, times by 3 gets rid of the divide by 3, I've still got to multiply by 5, minus 25x. So bring the 25x over to the other side, add it to the 9x, gives us 34x. Bring the 90 over to this side to take away from 200, gives us 110. So x is 110 over 34. Okay, but I don't want the x ordinate particularly. I want the y, because that's going to give me my perpendicular height. So we're going to have to sub that back in to one of these equations and find the corresponding y. So let's use this one that's right here. 40 thirds minus 5 thirds of 110 over 34 gives us tapping away on my calculator here, 135 over 17. So that's the y ordinate at that point of intersection. So we know that coordinate now is, I'm not going to squeeze this on there, I don't think. (110 over 34) is the x. And what was the y again? 135 over 17. Alright, so now we've got that. That's the perpendicular height of this triangle. It's 135 over 17. We know the base is 18, so we can work out the area using our good old half base times height. Half times 18 times 135 over 17 gives us 1,215 over 17. Your calculator will return a fraction in its fully simplified form anyway, so you don't need to worry about that. They're usually, the Casios are usually defaulted to return an answer in the form of a fraction in any case. So there we go, there's our area.